Welcome back to BioE 399. I'm your instructor, Dr. Craig, and today we're talking about this equation and how it relates to fermented foods like yogurt and many other things. This function is called the Gompertz function or Gompertz curve, and it's a sigmoid function, meaning it's like an S-shaped curve, and it's a special case of a logistical function. In this function, A is your asymptote, that is your carrying capacity. B is your displacement along the x-axis where your function starts, and C is the growth rate of the curve, or your organism in this case, and E is Euler's number 2.718. And this is what the curve looks like if it's plotted. You can see that characteristic S shape. But what does this have to do with fermented foods? Well, this equation is used to model things like growth, namely population growth. Originally, though, it was used to model things like human mortality. So let's look at how yogurt is made, for example. If you didn't know, yogurt is a fermented milk product where you take milk and you add certain bacteria to it. Things like Lactobacillus bulgaricus or Streptococcus thermophilus, or sometimes things like bifidobacteria. But you get the point. You add bacteria to the milk, and the bacteria will take the sugars in the milk and convert them into other compounds, and eventually you get yogurt. Specifically, if you want to know what's happening, they're taking the things like lactose and casein and converting it into compounds like lactic acid, which will give yogurt its sour taste. So if you ever tasted plain yogurt and it tastes sour, that's where that sourness is coming from, the lactic acid. And this is why it's also called lactic acid fermentation, because the product of the fermentation reaction is lactic acid. So when you're making the yogurt, what you want to do is you want to add enough bacteria where the fermentation reaction proceeds at a reasonable rate and not too fast, not too slow. So say you were making yogurt on an industrial scale, what you would do is you would model the rate of bacterial growth. And initially, when you first introduce the bacteria, it's going to go in that lag phase. Basically, they're adjusting to a new environment, etc. And then once they start growing, they'll start growing and dividing really fast. This is where your Gompertz function would start to kick in. You see that S-shaped curve starting to form in, and you're reaching that exponential growth phase. But eventually, you're going to reach something called the carrying capacity. That's essentially the capacity at which your system, in this case the yogurt or the milk, can sustain a certain number of bacteria uh, and no more. If it goes over that, then the bacteria will start to compete for resources, and they all start to starve. And then you reach that next phase, which is the death phase, where the bacteria start to die off. And these things are going to be a function of things like growth temperature. So at a higher temperature, it's going to be faster up until a point the bacteria are still comfortable at, or the nutrient sources that are in the milk other than just the milk. And if you didn't know, yogurt does contain live bacteria, but they're good bacteria. They're good for you. They are a part of your normal gut microbiome, and they're good to have. So yeah. But yeah, Gompertz models can be used to model a wide variety of different things like population growth, cell growth, including things like human cells, and even in the cases of things like cancer cells. Modeling is a really useful tool in a lot of applications, especially in science and engineering. It allows you to test hypotheses without actually doing the experiments. And then when you do the experiments, you can compare the results from your model and your actual experiment and see if the data fits. And if it doesn't fit, then you can either refine your experiments or models to help them match, or you can look at what's causing the mismatch between your models and your experiments, and that could also tell you a lot of information. But that just goes to show you something as simple as growing yogurt can have the same mathematical principles behind it as studying cancer growth. I hope y'all enjoyed that video. Let me know if you have any questions. Leave them in the comments below.